We can make it short.
Are you going to ask us questions about metalloids?
I think go to this.
No.
No.
I'm going to ask you where they are.
Oh,
Where are
really? We need to know where they are in the...
Yeah, where are they? Where are they in the periodic table?
They're in the middle of the non-metals and metals. It's like this weird row thing.
Yeah, it's in the staircase. Metals and non-metals. So what are some properties of metals? We've already said that they are malleable.
Shiny.
They are shiny. What's another word for shiny? They have luster.
Yeah.
Yeah. Luster. They're not lustrous.
Malleables, they can be
They can conduct electricity.
They can conduct electricity and heat. Good.
And they have 1 to 3 valence electrons.
Conduct heat.
They tend to lose electrons.
Lawrence, can you say that one more time?
1 to 3 valence electrons.
1 to 3 valence. This is key. And because of that, Pauline, what happens?
They tend to lose electrons.
They lose electrons easily. They can't hold on to them.
And there's solid.
At room temperature, they're most solid.
Wait, they conduct electrons?
Electricity, that's moving electrons. So I'll do that. Okay, there's a moving electron. That's electricity.
Mr. Sand, after this list, can you just show us an example of what type of question you would give us with metals?
Yeah, I'd say a metal is something that, and I'll give it a whole list of traits, and you have to circle the trait.
3.
So it might be any one of those three. It wasn't a phone, was it?
What?
Uh-oh. Today's one of those days where I'm strict about phones.
What? Could it be recorded?
Because of that. Okay. Metals and non-metals. What if we have a chart like this?
Which one's the alpha?
Do we need to actually circle where it is and stuff?
If I point, you tell me what I'm pointing to. Okay, ready? Oh, I forgot to do this. This.
Metals.
Oh, are you going to give that?
This.
Non-metals.
This.
Metalloids.
Metalloids. Good, that's it.
Wait.
What about it's not right?
Can you do it again?
That's no.
Non-metals.
Non-metals?
Non-metal and non-metal.
Wait, but that's easy because if you know where the gases are, that's non-metal.
Yeah.
Then metalloid has to be in between.
Say it one more time so people can hear that. That's a good thing to say.
Well, if you know where the gases are, then you know those are the non-metals, and then the metalloid has to be in between. So.
Yes.
You're gonna tell us to say which elements are non-metals.
Wait, are you
You are.
going?
Yeah, but it's on the periodic table.
No, but that's difficult because we have to.
Wait, so what goes under?
I'm not going to have you guys memorize the exact staircase. I just need you to know that the stair. You know what I'm talking about when I say the staircase?
Yeah.
I'm talking about
Right
this.
there. That's the
dividing line.
That's the metalloids.
I'm going to give you regions, and you label those regions.
Oh, okay.
Not the staircase.
But you're not gonna give us
Mr.
this.
Staircase.
Okay, so it's like non-metal.
Non-metal
Yeah.
is on the top left and the top right. This is the gases.
Okay. We're going to hear this recorded, and like through everything, we're going to hear Brett's voice going, "But Mr. Sam, what is this?" So it's a little bit whiny. I'm just being honest. What was your question? No question anymore. I don't want to give you a question now. Okay. Okay. No more.
It says what goes under non-metals.
What goes under non-metals?
Brittle.
Metals? Oh, what goes under non-metals for this?
Yeah.
Ah! Okay, it's the exact opposite.
Do we need to know that?
So for non-metals, it would not be malleable, it would be what? Brittle.
Oh,
No,
Right?
it has 6 to
For-
8.
It would be dull, not luster.
4 to 8, I think so.
It would not conduct electricity or heat. It would be called something we call a
Insulator.
insulator. Yeah, good. Insulator.
Smart.
Insulates. Instead of 1 to 3 valence electrons, it would be 4 to 8. And they would hang on to their electrons. In fact, they would grab extra electrons.
That's why they don't conduct electricity, right? 'Cause they don't-
Yes, that's exactly right. You can even boil all of this down to effective nuclear charge if you really want to. Right? So they really attract the electrons. So they're not going to give any away.
Wait, what's the opposite of malleable again?
Brittle.
So are you gonna on the test say like this substance is malleable? It's also an insulator. So then we would say that it's
Well, malleable and insulated, then it would be like a metalloid.
Yeah, so we'd say that the metal would, that
Yeah.
would be one of the choices.
I'd make it very obvious if it's a metalloid. I'd also make it very obvious if it's a metal or a non-metal. So you just, basically what you need to know is that
Saying this test is obvious.
These characteristics.
you need to, yes, I'm saying it's obvious. You're going to need to know, it's not going to be like a trick question there. I just want you to know that you know the basic properties of metals and non-metals. Okay? Yes.
Do nonmetals gain electrons?
Okay. Do non-metals gain electrons? Yes.
Okay.
They gain electrons. Okay. What else? Let's talk about trends and then Mendeleev. Trends are the backbone of this whole thing.
Okay, I understand what I'm trying to, but I don't understand.
Okay.
What you talking about?
First, let's define what these trends are. First of all, just like the traits that we're talking about that increase or decrease. Then we'll talk about how they increase or decrease going across and down. Then we'll explain why they go up and down as you go across and down.
Well, what would you say?
What'd you say? What you talking about? Atomic radius. Atomic radius is what? Atomic radius is the distance between,
The nucleus and the valence class.
yes, nucleus and the valence shell. Valence electrons, valence whatever. The outside electron. Right. That is a trend that as you go from left to right across the periodic table, it decreases. Now here is our most difficult explanation of all of them. It decreases because, and this is the hardest part, why does it decrease? There are two possible answers. One of them has two steps, the other one's pretty easy. So why, what is going on here? You are just, you got like ants in your pants right now. We've got, no, it's okay. We have two explanations for why the atom gets smaller as you go across the periodic table. What's one explanation? Lawrence?
Well, the number of shells stays the same, but the photons are increasing. So
Yes, you said everything in that in like 2 sentences. It's amazing.
Can you repeat that?
Say it one more time louder so the mic can pick it up.
Can you say slow enough?
the number of
No, that's not the mic. That's Don's hand.
the number of shells or rings stays the same as you go across.
Yeah.
The number of protons increases, so the Zeph gets higher.
Yes.
That was kind of quick.
So you said the number of shells
Can you write it
as
on
you
the
go
board?
from left to, I'm just going to say it. I'm going to say it and you're going to think it
No,
and then you're
write
going to write it.
Alright.
As you go across the periodic table, the shell stays the same. So you're in the same row. Okay? The shell stays the same. Yeah, the shell you're adding electrons to. Okay, so the shell that's on the outside stays the same.
Wait, so basically you're saying, on the periodic table,
On the periodic table,
if you're going like this,
when you're going left to right,
that will be the same shell.
when you're going from
Left
left
to
to right,
Yeah,
like
oh,
this,
left to right, left to right.
you're staying in the same row, right? Here's the same row. As you're going from left to right, the electrons are added to the same shell. That's the first part. Then Lawrence went on to say, but you're adding protons. So each electron sees more positive charge, making it more attracted to the nucleus. Okay?
So higher.
So there's two steps to this. The first step is that you're adding electrons to the same shell.
No, you said as you go across the periodic table, the shell stays the same.
Yes. So the shell stays the same. The same shell you're adding electrons to as you're going across the periodic table. Okay? Got it?
Dude, it's like,
Can you just
if you think about it.
Do you want me to write it down?
Yes.
Oh my god.
I'm a visual learner.
But that's writing.
It's really easy though.
As you're going across the periodic table.
I can demonstrate in a
As
visual
you
way.
go across the periodic table. You've written this down so many times. This is the periodic table. I'll erase the other stuff so it's not so cluttered. As you go across the periodic table, you add electrons to the same shell. You also add protons, which makes the electrons more attracted to the nucleus.
Well, it's a long sentence.
I know, that's why I didn't want to write it. Okay, as you go across the periodic table, you add electrons to the same shell. You also add protons, which makes the electrons more attracted to the nucleus. This is a long explanation, I know. This pulls, I like pulls. This pulls electrons closer to the nucleus. And makes it smaller. Or making it smaller. What's another way to say this? Lawrence, you said another way of saying it. You said it just increases the effective nuclear charge.
Is that going to be tested on reactivity or not?
Reactivity.
Oh yeah, can we
Yeah,
start
we'll talk about that too.
So we don't
This
test
is the
it.
very end, okay? Don't let me forget that. Reactivity. All right. So another way to say all of this, as you go from left to right on the periodic table, the effective nuclear charge increases. Another way to say this equals effective increases. Effective nuclear charge increases. That's the same thing. Okay? I'd accept both of these answers. Here's one. Here's one. Here's the other. Okay?
Maybe you can literally
Wait, so
just say
basically
because
that increases when you go left to
Yes,
right.
I understand what effective nuclear charge means.
Okay.
You understand what effective nuclear charge means.
So that's only one of the things.
Yes, I know.
So now there's two.
If you think about it, the
ionization.
atomic radius.
Yeah.
Wait,
Wait,
so
so if we just put Zeph in,
These-
we get full credit.
These equal the same.
Wait, Mr. Sam.
Well, yes, and then yes.
So if we just put Zeph increases for the answer, that would give us full credit on the question.
This one is more complicated. People like to say the protons increase. That's why it gets smaller. That's not the main reason. The main reason is protons increases, and you also have these electrons added to the same shell. Okay? You could also say that the effective nuclear charge increases as you go from left to right across the periodic table. Okay? Right?
Why does
I accept both of those answers. Now,
I can
I'm
see
not
that.
making you define what this is. Maybe I should, but I'm not making you do it.
No.
Wait.
Effective nuclear charge is just a charge felt by electrons.
Okay.
That's it. Yes.
So basically, as you go left to right, Zeph increases.
Yes. Okay, that's it. So now the trend from left to right then is the atomic radius decreases. It gets smaller. Right? We're going to hit on that in just a second. Let's go down the periodic table now. Down the periodic table. As you go down the periodic table, the atomic radius increases because
More shells.
the shells, more shells, and Zeph does decrease too.
More shells
Wait, we're gonna say Zeph decreases.
For that one, you could say either one. You could say the effective nuclear charge does decrease. But